I'd like to see code change so that the code actually delivers healthy, comfortable homes for people. I'm surprised that some smart lawyer hasn't sued the government yet for the fact that it doesn't do that.
It's this inequity. The argument was, but then everyone can afford to build the same house with R2 insulation in the walls. Across the country, it's the same kind of cost. But it's not. It's not the same house. You're not getting the same performance. How much more insulation we really needed to make these homes comfortable.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. You can also check out our Reimagined Buildings YouTube channel for some great inspiration for both building new or renovating. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from a cold, wet, windy, wintry Auckland.
I'm Zach Semke, coming to you from a beautiful, sunny Seattle, Washington. It's gorgeous.
We are past the solstice now, so things are looking up.
That's right.
I did hear that we're in for some more settled weather coming up for the rest of winter, but we've had an astonishingly wet year for the first 6 months of this year.
We're feeling fortunate to be breathing clean air in Seattle. Unfortunately, our compatriots in the Midwest and now the East Coast are getting blasted by those Canadian wildfires again. Maybe just a little, not quite as bad as it was before, at least in New York, but there were some pretty severe temperatures. That's right, and there's
south last week.
Basically a heat dome going on in the south. Now it's continuing. Yeah. With temperatures 20 degrees Fahrenheit higher than normal. Yeah, pretty crazy.
Yes. Anyway, well, we've got another interview that was a result of the Thrive conference in Sydney earlier this year. Really enjoyed hearing from two former guests of the show, Talina Edwards and Andy Marlow, who have been on the podcast before, back in pretty early on, episode 15 for Andy and episode 28 for Talina, so you can check them out. They've subsequently, from those interviews, joined forces. So Talina Edwards had her own practice and actually joined, and they operate out of different cities but have a combined practice. Before we get into that, we've got a few people to thank for all their support.
Indeed. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
So a couple of things that jumped out. I mean, this was the opening presentation of the Thrive conference in Sydney, and there's lots to like about it. So the presentation from Talina and Andy was a rundown of their success in a design competition that was focused on carbon. And I found this really interesting, that carbon interest in both embodied carbon and operational carbon is coming to the forefront in so many different areas around architecture, design and building. People definitely taking notice of it and thinking about how we get to a lower carbon future. And I'll let Talina and Andy explain a bit more about the competition, but basically they dramatically overachieved in terms of the brief of what was required, which was basically to design a house in a a city in Australia, and they ended up putting that same house in all capital cities around the country to see how it would perform in different regions and compared a whole bunch of different metrics. So really fascinating stuff, and lots of very interesting results. You probably hear a lot of talk, well, you will hear a lot of talk about NatHERS, which we have talked about on the show. That's the NatHERS as a rating system. So it's the National Home Energy Rating Scheme. Pretty much all Australians are very familiar with that, even those not involved in the industry, because it is pretty well known. It's been around for a while now, and it's what's required for most houses when they're new, and also when they're sold. You have to get a NatHERS rating. So that's sort of a well-known metric, and I think it's fair to say that it came under a little bit of fire during the Passive House conference. There's a little bit of critique of the methodology behind NatHERS. It's always interesting to see something that is used by the mass market and therefore has to be a little bit simplified to use. And there are obviously some downsides to that simplification. And this type of analysis is really good to look at what are the pros and cons of having a mass market kind of tool versus something like PHPP, which is a bit more detailed, but can potentially give much better results. So I'll let Andy and Talina get into it. Now, they do, of course, talk about R values a little bit in here, and we're talking metric R values. So if you're wanting to convert that to US, just multiply it by around 5.6, 5.7, and that should give you a bit of an idea of what we're talking about. All right, so let's kick it off. Here's my chat with Andy and Talina. Welcome, Talina and Andy. Good to see you guys.
Good to see you.
Good to see you too.
Just been chatting, and it sounds like it's winter time in our part of the world. You had a cold site visit, Talina?
I did, 1 degree, but it was a passive house, so it's going to be lovely and warm to live in.
Yeah, I think it's a good reminder that Australia gets cold.
Absolutely. People think it's the sunny country all around, but not in our part of the world. Yeah.
So both will be familiar to some people, some listeners. Talina, you've been a guest on the show. I think you've been a guest as well, haven't you, Andy? You've been
very early on.
Probably separately as your separate entities, but now combined forces. So, Talina, tell us about the merger and who Envirotecture is.
Yeah, so Envirotecture have been running for over 25 years now, leading in sustainable design. And it was around the same time, close to probably nearly a decade ago, which shows our age, that, both Andy at his end and me at my end, operating as Talina Edwards Architecture, was starting to learn about Passive House. And some of that was from your first podcast too, Matthew, back in the day with Homestyle Green. And so we were on that similar journey, attending getting involved with Australian Passive House Association, attending the conferences, and our first projects were sort of completed at the same time. So there was a natural progression with helping each other out and answering questions for each other over the years. And it helped strengthen both of our practices and both of our learnings about Passive House, I suppose. And over time, we realized that as two smaller businesses, we could only do so much. And as everyone knows in the Passive House world, we're sort of stronger together once we can share this information. So after a while, we thought, why don't we join forces and try and have a greater impact across the country? So that's what we did. So we've now got offices in South Wales and Victoria.
Right. And do you split the services? Because Andy, is your expertise more in the consultancy and Passive House technical side of things?
No, ours has always been the blend of architecture and the building sites. So we're pretty good at the technical, and we do a lot of consulting to other designers. which is, well, we think good for them because we kind of understand how buildings go together. A lot of engineers may not always get some of the practicalities, especially at the residential scale. So we've done similar things in terms of what Talina was doing before the merger and after. And really, we did, as she said, we just hit a point where we ran out of reasons not to. So here we are, 6-7 months in, eh?
Yeah.
And all is rosy.
And what would you say is what's the state of the market for what you do across Australia and across the regions that you're operating in?
Booming. Still booming. It's been booming ever since about 6 weeks after COVID started. It was booming anyway, and then COVID just went nuts, and it hasn't slowed down yet. So,
and so when you say booming, is that the construction industry in Australia in general, or just the subset of the construction industry interested in what you have to offer?
It was everybody, and the whole thing went nuts, which is part of the reason everything's gotten quite expensive. But as everything else is tailing off, the passive house world does not appear to be tailing off yet, anyway. So lots of builders, lots of regular sort of jobs for builders are falling over for various reasons to do with money, mostly in various forms. But the passive house stuff is still going along tickety-boo.
Yeah.
So
good to hear.
Yeah, it's good to hear. Yeah, it is. It's really quite reassuring.
Yeah, there's a much greater awareness now from 5 years ago even. Back then you'd say passive house and it was still, passive solar. And now there is way more recognition of what it means. So it's who doesn't want it once they learn the benefits? We don't have any client come in the door and not want passive house, really.
Yeah. Now, I want to talk about Little Pot of Gold, but also the research that you presented as the opening keynote of the Thrive conference earlier last month in Sydney, which was it kind of set for me, and I think a lot of the attendees, it set the scene for the 2 days of great presentations. So maybe, Talina, do you want to start off with telling us a bit about what the Little Pot of Gold is, and also the basics of the competition that you entered?
Yeah, sure. It started out as a design competition through one of the building designer organisations in Australia called Design Matters National. We are members across different architecture and building design associations across the country because we believe there's value in all of those. And this one is particularly, they were trying to step up and say, how do you go beyond, previously it was a 10-star challenge. And they were trying to promote more sustainable buildings and use it as a learning opportunity for their members too, to step up and learn more about better home design and looking at low embodied carbon as well as operational energy. So this one was called a True Zero Carbon Challenge. And you could pick one state capital city in the country to design one home, and it had to be a 3-bedroom home, and they gave us the site. It was a single family home. And we sort of sat down and thought about it and went, wouldn't it be good to, I think it must have been Andy's idea. And we went, is this a good idea or not? Design one house, put it in every capital city and see what happens. But also, what if it was passive house? But also, what if we looked at low embodied carbon and then sort of a standard construction? So low embodied meaning using hemp and straw. Medium embodied carbon meaning kind of typical lightweight construction, or a high embodied carbon using more concrete and some internal brick walls. So we thought, what if we did these 3 options as passive house and just ticked the code compliant NatHERS box? What would that look like?
Right.
And yes, this sent us on a spiral to do 24 different versions of a competition.
Right. Slight overachievement there.
Yeah, I know. We're nerds when it comes to this stuff.
So just for our overseas friends, NatHERS is we mentioned a few times on the show, it's the National Home Energy Rating Scheme, and that's the 10 stars that you're referring to. Is that the top of the scale?
Yes, it is. At the moment, around the country, they have moved to 7 stars, but not all states have kind of officially done this yet. So now, in many places, 7 stars is now the legal standard you can build to. But we wanted to test this because there is a large reliance on high mass materials, thermal mass, to get your star rating. And we weren't sure if this was actually going to give the best benefit, especially when you're looking at the embodied carbon and the payback period. And look, as part of the competition, we had to do try and calculate this in terms of the embodied carbon of these different materials, which, the world's catching up. There's a lot of different ways you can do that. We know with Passive House we can take care of the operational energy side really easily with the PHPP. The NatHERS is calculating things a little bit differently. So we just wanted to highlight some of those findings, or what's become, myths, and what is more true about the outcomes. Yeah. So in the end, we ended up with sort of 4 key areas that we were questioning, which was around embodied carbon, affordability, equity, and the performance gap.
Right. And NatHERS is required in Australia, or is it all states, or what's the requirement for NatHERS when you're building a new home?
There's a few different ways you can make compliance with the building code, but NatHERS is the most commonly used across the country. Right. There's a few other weird ways that some people, especially in Western Australia, which is almost its own country, use over there. But yeah, it's the way that most people get stuff approved. And like Talina said, we're about to go to 7 stars. At the moment, it's at 6. But because it's actually state-based, even though it's a national construction code, the states choose which bits to adopt and which not to adopt, which of course is ridiculous. And therefore, like Western Australia are not doing it. Northern Territory, I don't think they've adopted the last change yet. Like, it's a dog's breakfast.
But I guess what it does have going for it, because there is a element of requirement there, it's got pretty good brand or name recognition in at least the building industry. Would most consumers know what NatHERS is?
Yeah, look,
I don't know. It depends on the consumer.
Right.
Yeah. Look, we don't want to be completely dissing the fact that it exists. It's come a long way. Without NatHERS, our homes would still be all the wooden tents that were built 100 years ago, right? So it has come a long way. We just feel it needs to go that next step.
Yeah.
and be doing better, right? And it does change over time, and they do this sort of stepping up.
Yeah.
But it's not necessarily delivering the outcomes that people expect. There's still this widespread knowledge, and especially here in some of the colder parts of Australia, you buy your 6-star home, people expect that they're going to walk in and it's going to be comfortable and healthy and energy efficient. And the reality is it's not.
Yeah.
And they don't understand why, because it's this miscommunication and misrepresentation about what they're actually getting. And we don't think that's fair. Is the reason we called it Little Pot of Gold is because there is this whole thing about constantly trying to grab those 6 or 7 stars and thinking that that's the best you're going to get, when really it's not. So our sort of tagline there was, should we be reaching for the stars, or are we chasing rainbows? Are we constantly trying to get to this goal and never quite, reaching desired outcome? And that's why we called it the Little Pot of Gold. And Andy can help explain a bit more about the gold nuggets that we found.
Nice.
Yeah, it's a shame it's not video. The actions that went with that explanation.
Yeah. Talina is very enthusiastic.
Sorry.
Look, Talina sort of rattled off the 4 key things that we came to. Big one, embodied carbon, which is huge and currently just not it's almost on the radar here, but not really. So we looked at the embodied carbon of each of these 24 options. We built our own tool because the tool the competition gave us didn't really work for buildings at this scale. It's good if you're doing a skyscraper, but we weren't, and therefore it wasn't very practical. And basically, we sort of unsurprisingly found that there was a correlation between the embodied carbon and the star rating. So between thermal mass and the star rating, and there was a correlation between thermal mass and embodied carbon, because most of it was assumed to be concrete or brick. So what we were trying to draw attention to really was that chasing the stars also, in the way that it's currently being done, is also increasing embodied carbon. And then all the other stuff was showing that there wasn't necessarily a relationship between the star rating and the performance at all. In fact, it was not much. And therefore, these two things, thermal performance and thermal mass, are not connected. They don't have to be connected, but the system we have has effectively put them together. And we're saying that doesn't make any sense. So lots of it's to do with the internal workings of natters, which, like Talina said, isn't fundamentally bad. It's just got some weird settings in it that need to change. But there's a bunch of reasons that those exist. And until the political decisions are made to fix them, then we're going to be in the same sort of problem. So
does NatHERS consider infiltration and air tightness at all?
Yes. So up at the moment, in terms of in regulatory mode, so you can turn off regulatory mode and tinker with a few things, but at the moment, when you do regulatory mode, it has a setting in there which you cannot adjust. It's meant to be a dynamic setting, i.e. it depends on the weather, because they use hourly weather data, and therefore it depends on the weather as to what the infiltration is, which sort of makes sense because it's wind-based. And it's considered to be somewhere between maybe about 10-ish, but no one's entirely sure because it's not that easy to actually pull it back to the way that we as passive house designers think of air tightness. So it is in there. Whether it's realistic, but whether it's realistic is a whole other question.
The assumed infiltration rate is around 10 air changes an hour.
Ish, yes. But then the only study we have in the entire country about air tightness of regular buildings, which the CSIRO did like 5 or more years ago, is that the average of new houses, forget old stuff, was 15.4.
And that
was the average.
Is that the natural infiltration rate, or is that at 50 pascals?
That's 50 pascals, blower door tested.
Right.
And if you actually go look at the chart to where the average came from, there's 2 houses right at the bottom that were like 1 and 1.4, which helped to drag the average down.
Right.
And that was due to what we call Justin, who, for those who know, Justin O'Connor down in Tasmania. So if it wasn't for him, the average would have actually been higher than 15.4. So
right. So I mean that's kind of what I took from listening to your presentation, was that it was overemphasizing the importance of thermal mass.
Yeah. And our key point is that because most thermal mass is high in embodied carbon as well, that this is a big problem because we don't have enough carbon left to faff around doing this. So the other thing that flowed on from this was that in design land, it's always been, it's okay to use concrete because you'll save operational energy later.
Yeah.
And in a not very good building, that's okay. But as soon as you have a high performance building, it's like, well, no, actually, no. And you basically got to the point where over, 27 years, because it was from here till 2050, that operational energy in a passive house is about the same as the embodied energy, the embodied carbon. So they're proportional.
So say that again. The operational energy ends up being the same as the embodied.
27 years worth of operational energy looks to be about the same as the embodied carbon to get there. Now that's assuming that your that assumes your operational energy is sort of standard grid stuff. Obviously, if it was from PV on your roof, it's a different story, because then it's even more important to sort out embodied energy. So
and
the key messages.
Yeah, and are there some assumptions in there about the Australian power generation? Because you don't have particularly green energy at the moment, do you? I mean, you're sort of weaning off pretty dirty coal for most of Australia, but that is likely to change over the next, well, hopefully, will change over the next couple of decades.
Oh, yeah. Yeah, so the embodied energy, this is the whole thing. embodied carbon looks currently to be kind of 50-50, then you, like you say, play through what's going to happen to the operational carbon intensity, assuming that you just plugged into the grid, which most passive houses aren't anyway, or not permanent, you know what I mean? And and all you can walk away and go is, oh God, embodied carbon's the thing. Yeah, like it's all that and retrofit are the only things that are
often
left.
There's still the argument around, you put all that embodied high thermal mass in there. Just put some more solar panels on, or don't worry about fixing up your insulation, just put on more solar. And for the competition, there was a constraint around not putting more than a 15 kilowatt system. So all of the payback periods and everything were calculated on that 15 kilowatts. But we worked out that was about 12% of the total house embodied carbon, just the solar panels alone. Put more of them on, that's also more. So it brought us back to the whole efficiency first argument and lightened up.
Because they are one of the higher embodied carbon products that you can put on a house as solar panels. What about, is there an assumption in hers about the use of, or the effectiveness of thermal mass? Because it that assumes, having concrete in the structure of the house, that it's useful by virtue of being exposed. But how often is that the reality, that all that thermal mass is even useful?
Not where we are.
Anyway. Not exactly sure how it really deals with that. I mean, it does. I'm not a NatHERS assessor because I don't find the software very useful. But it does. If you tell it you put carpet over your concrete slab, it will take away some of the benefit of that thermal mass. So. I mean, it is the engine that runs behind the scenes in NatHERS. Like, there's all these sort of different front ends that go over the face of it that are sort of the interfacey bit. But the engine behind it, from all the people I know who are proper smart, like, the engine's really, really good. The issue is the assumptions that are plugged into it that are causing these weird, the results that it is. So
So, are there any surprises that you found? I'm assuming that some of these findings you kind of suspected at the outset, and it was a good opportunity to prove the value of PHPP. What were the surprises or unexpected results?
The one that probably actually partly surprised me, but also just reinforced something I'd forgotten, which therefore was a surprise when I remembered it. We put a fair bit of energy into the cost side of things, because you're supposed to cost this thing. So we got a QS to do it. He costed a building. We pulled that apart and then recosted it using rates to allow for the different amounts of insulation. Because obviously this building is geometrically the same in every location, but we're having to make the walls fatter or thinner, or the roofs fatter or thinner, and do all this stuff to it, or change the windows from double to triple glazed, whatever, in order to make it meet Passive House standard. So we did all of that and crunched all those numbers. Matthew, you may remember, like 4 years ago, I gave a talk at another South Pacific Passive House conference about the cost of the Thornlea house that we finished. And it, funnily enough, and I realised this the day before we gave this last talk, it gave the same answer, which is, when you look at the cost of building a house, in Australia at least, approximately 25% of the cost of your house has got anything to do with the thermal envelope. So walls, roof, floor, MVHR, and windows. The other 75% is stuff. It's the builder's margin, it's insurance, it's the kitchen, the bathrooms, all those other bits and pieces.
Ensuite, walk-in wardrobe.
Yeah, all the other bits. Not saying they're not necessary. Some of them may not be, but the point is, and so the big takeaway from this was, the cost of building well isn't the problem. The cost of building is the problem. And about 25% of that problem is caused by the thermal envelope, even if you build a shit building. I mean, so you might save 5% or, a portion of the 25%. In the scheme of things, it doesn't stack up. So you might as well build it well anyway.
Yeah, well, that's another important point about that 25%. That's not a 25% premium for doing passive house. That's a lot of that 25% you're going to have to do anyway, because it's things like insulation, which you're required to do. You're just saying that the bits that make a difference are only in that 25%, and
Yeah.
So your margin, your increase in going to passive house is a premium on that 25%, not the overall.
Exactly. And that 20% is structure as well. Like it's the walls
Right.
that happen to be insulated.
Right.
So, you know,
Yeah.
you could take off your lovely vapor permeable wraps and you could use slightly less good insulation, but you're still going to end up with the same timber frame.
Yeah.
Yeah. So
I think that's a really good.
So,
I think that's a really good point because it separates out because we often hear about housing affordability, and it separates out some of that part that plays into that affordability of building cost, which is going to happen anyway, regardless. And that so often gets pointed as a reason for not building a decent home. So I think that's a really useful way of looking at that and saying, those are kind of costs you're going to have regardless of whatever house you're going to build.
Yes. I mean, the other way to look at it, of course, is why would you spend that much, save yourself 50 grand or whatever that number might be. Why would you spend that much money on something that doesn't work? Like if it's still $800,000 or whatever the number is, that's a lot of money to spend on something that doesn't work.
Yeah.
You'd be cranky if your phone died, and that didn't cost you $800,000.
Yeah.
There were also laws. So,
what were the surprises or outtakes for you, Talina?
I suppose when we got stuck into some of the stuff around equity, and this has come up a fair bit for us over the past few years, particularly understanding the balmy Goldilocks Sydney climate, perfect every day apparently,
sure.
Compared to some of the other colder parts, inland, where sort of central highlands, north of Melbourne, but, in inland areas are often a bit more cold, and also down in Tassie. And so the understanding the way that the NatHERS star rating was quite interesting for me to really I'd heard this many years ago, but really as we did this deep dive, it was understanding that so a 7-star home in Ballarat here can legally use 5 times the energy of one in Sydney. And it's like, This is what I'm saying about, it's this inequity, and there's all these, the argument was, but then everyone can afford to build the same house with R2 insulation in the walls. Across the country, it's the same kind of cost, but it's not the same house. You're not getting the same performance. We need way more. And this is as we started the passive house journey, realizing how much more insulation we really needed to make these homes comfortable, or how much the form factor really mattered. And it just really made us understand, like, this is not fair. It's not fair on people who live in other places who think they're getting a comfortable home and they're not. And it's not,
So the equity needs to be from the perspective of operating cost rather than just build cost.
Well,
I'd say it's about comfort. It's the health outcome, because the operating cost will have the same problem. Like if Talina and I had equal houses in our respective places, her power bill would theoretically be 5 times the size of mine.
Yeah.
So it's weird. They chose the equity to be every Australian can build the same house regardless of where they are. Effectively, that's what the numbers look like. Obviously, the problem is that if you're in Thredbo, which is a ski resort, pretty cold.
Yeah.
And this brought us to that whole idea too around the lock-in effect, which is talked about a lot in the passive as well, the idea of resilience. If this is what we are locking into our current housing stock, and it's not fit for purpose now, let alone there's already a huge retrofit market, or homes that require retrofitting desperately, but we're just creating more that are going to need to be fixed up. The day after they're built, they already need to be fixed.
Yeah. So just to wrap up, I'd encourage people to go and have a look and find all the stuff that you've put out and the results. Fantastic result for that competition, and congratulations to you both. Where would you like to see things go from here? What would you like to see as a result of the work that you did?
I'd like to see code change so that the code actually delivers healthy, comfortable homes for people. I'm surprised that some smart lawyer hasn't sued the government yet for the fact that it doesn't do that. Some of the new provisions of the code have been proven by people to actually be guaranteed to cause condensation and mold in the building. But it's still in the law. I'm not a lawyer. I don't understand how that works. It seems nuts. So yeah, we'd like to see that sort of change. We don't think it's actually that hard. There's many examples of, JFK saying to go to the moon, all these kind of things. People, when they're given a task, can make it happen. The problem is no one's actually set the task. Everyone's dilly-dallying around. So onwards and upwards.
Anything else from you, Talina? What would you like to see from here?
I don't think I've got anything to add. I just want to see everyone living in healthier, comfortable, beautiful, more resilient homes. I just feel like it feels like it goes back to partly of that being a human right, that we deserve a safe and comfortable house. And one of the biggest takeaways from the recent conference was some of these homes, they are causing sickness and health issues in a lot of our kids, especially, whether that's asthma or other issues, elderly. It's putting pressure on the health system, I suppose. So that's the other argument. I think before long, insurance companies and others, the lawyers, they'll all be getting onto this and wanting, because how much money is spent on health every year? If this can be considered part of preventative health, it'd be great to see an improvement there. It feels like we've got a duty of care, right?
One other thing that does bring to mind that I guess I'd like to see slightly less of in some ways, we fairly frequently come across people who, in generally biggest organizations, who claim to be seeking change and are generally humans who genuinely care, but haven't, for whatever reason, been able to get stuff over the line. And yet, when you interrogate what it is they've been doing, fundamentally, they've been trying to retrofit, pardon the mixing of metaphors, retrofit a passive house strategy onto everything they currently normally do with the people that they have historically used. So it's sort of it's a hammer, everything is a nail. So they're trying to get the same design teams and the same building teams and the same engineers to deliver the same house, but make it a passive house. And obviously anyone who's delivered more than one passive house knows that that's not the best way to do it. It's not the most cost-effective way to do it. It's not the easiest, least stress way to do it. And it's just, so anyway, we are hopeful that some of those people in those positions manage to sort of branch out beyond their comfort zones in that sense and engage with the people who actually know how to do it, rather than get the others to get on board.
And certainly the need for further education and increased awareness training across the industry that certainly came out throughout the rest of the conference as well. Awesome stuff. Great opening to the conference. Really helped set the scene, and there were lots of mentions about NatHERS. I take a point as well, Talina. I think it's easy to kind of kick it around a little bit, but it has achieved certain things, and I think your work now helps highlight where the improvements can be made and sort of leverage the strength of PHPP off of that need to have some sort of national scheme. Good luck, and I hope others do take up that challenge to really make some effective change. So thank you, and I encourage people to go and check out your work, and look forward to hearing from you again.
Thank you.
Thanks, Matthew. Good to talk.
And that was Andy Marlow and Talina Edwards, now both of the same practice, but talking about their project, The Little Pot of Gold. And we'll put links to the show notes. You can check out, if you just search up Little Pot of Gold and Talina and Andy, you'll probably find that, but also check out Envirotecture, and they've got lots of information there. What are your thoughts, Zach?
Well, so many great insights from this study and exercise that they went through for this entry. And well, a couple of things that I wasn't aware of. One was that there was such a focus on thermal mass in the NatHERS scheme. That means a bunch of embodied carbon, because typically that means a lot of concrete.
Yeah,
we already knew that, the whole mass and glass, as we say here, I don't know if you say that in Australia, but the high thermal mass approach to kind of passive solar design, really only works in certain climates. We also now, because we're so concerned, rightly so, about embodied carbon, have another reason to be skeptical of that approach to energy efficiency, because it means such a carbon burp during construction.
We do love our windows, glass walls, sliding
Right.
glass doors. So yeah, they are pretty intensive, as well as the concrete, obviously. It kind of reminds me of a similar change that I heard about over a decade ago, and probably started even earlier than that in the UK and also North America, and the sort of realization that light and tight is better than heavy, thermal mass. So this concept of light and tight, I remember Ben Adam Smith talking about that at least a decade ago when he was sort of just getting into passive house. And that is the concept of passive house, focusing on lightweight materials, but tightness. And that is really one of the main critiques of the Nat HERS assessment, is this heavy reliance on heavy materials. And no consideration for air infiltration. And we know from PHPP that that's a significant part of energy loss and internal indoor environment, and the just general quality of the building. And that's something I point out as well when I'm introducing people to PHPP is the concept of air tightness, and just how much of an impact that has. And the fact that you get diminishing returns after a while with your insulation. Certainly thermal mass is kind of limited. The reality is that most of even the concrete that we use in our typical construction doesn't contribute a great deal to the thermal mass sort of flywheel effect anyway, partly because it's covered in carpet, the top layer, or it's not well insulated around the edges. Right. And if it's not exposed, and if it's not getting direct sunlight on it to warm up, and that heat is being retained and then slowly released, it's not going to have any of very limited benefit anyway. So it ends up just being, as you say, a carbon burp during construction, with no significant benefit. So these studies are really useful. It was far from the only presentation during that 2-day conference that pointed a bit of a finger at Nat HERS, and I get the sense that there's pretty good momentum now in Australia to feed back into the powers that be to get that changed and start considering the impact of air tightness for better energy modelling, and also sort of highlight the impact of carbon.
Right. And, neglecting air tightness also has really important implications around resilience to wildfire smoke, bushfire smoke. Yeah. In fact, even embers as well. We just on the Reimagine Buildings YouTube channel, we just released a interview by Mary James on location with Mark Attard in Louisville, Colorado, which that was part of this is the site of the massive Marshall fire that burned down hundreds and hundreds of homes a couple of years ago. His house, he had just done a passive house retrofit of his house. Before that retrofit, it had 27 air changes per hour at 50 pascals. This is a code minimum built home in the 80s, really crappy construction. Like the entire subdivision was like this. He retrofitted it to passive house and simplified the envelope, and also electrified. So it really minimized the pathways for embers to enter the envelope. But it also meant that so I think that plus some good luck, honestly, spared his house from being burned down. But the fact that it was airtight and had filtered ventilation meant that when they came back to the house, it wasn't the interior hadn't been destroyed by the toxic smoke, and many of his neighbors had to do really intensive mitigation in their buildings, inside their homes, because they were registering toxicity inside. I know Australia, like the west of the U.S. here it deals with lots of smoke and fire, and we need to be thinking about both the kind of the ways that we can make our buildings more energy efficient, so we're not making this climate crisis worse, but also the ways that we can be resilient and safe from these disasters that will be more common.
Yeah, and possibly that's a foot in the door to introduce air tightness. I mean, that's a challenge in Australia and New Zealand. It's been done in Europe, North America. That challenge is overcome, changing the industry, introducing these concepts, and then facing the challenges of training enough people, getting it. That's kind of where we're at the moment, is we just don't have enough. It's arguable as whether we have enough testers or not, because you actually don't need a huge number, but we just need to get the ball rolling, so that we've got testers out there and that people recognize it as a valuable thing to do. And it also brings the cost down of doing tests in homes. But this goes a long way to helping raise the awareness of the benefits, and also ideally trying to get it into some of the standards and some of the building regulations as well, which is a long way to go.
Yeah.
I really like the emergence of designs that fit in different contexts, particularly that relate to Australia and New Zealand as well. Architects growing up in those locations and adapting concepts like passive house to fit that local environment, and we're starting to see that more and more. Size is a big part of that. The little pot of gold is 120 square meters, which they say is approximately half the typical house, which is pretty staggering. Also a little bit scary. Yet it still has 3 decent sized bedrooms and all the things that you would expect from a nice family home. So that's a big part of bringing down that embodied carbon, and the cost as well is changing the concepts around how much size we need to live comfortably, but also just the shape and the style and the design, the materials, designing for pretty intense summers, and keeping within those bounds of passive house criteria. So I really like those examples that are Australian or New Zealand in origin.
Yeah, absolutely. And the size of the house points to the general organizing principle that they are articulating in their work, of both Andy and Talina or Talina.
Yeah.
Sydney, I'd like you to cut that out, please. That both Andy and Talina, and that's the efficiency in materials, efficiency in space, efficiency in energy use. And it kind of alludes back to the lightness of the light and tight, right? That when we are efficient in all those ways, that means that we're reducing embodied carbon. Another thing that I think just to elevate is I really enjoyed the discussion Andy's statement that the cost of building well isn't the problem. The cost of building is the problem. Buildings are expensive to build. The cost of actually building a good building is not particularly high, and it's getting smaller and smaller as we're getting better and better at doing this work. The corollary to that, I think, too, is with embodied carbon, the main part of the embodied carbon impact of building a new house is simply building a new house. Building a new passive house, making it a better house does not have a massive embodied carbon premium. It can be a tiny, it can be tiny or even zero or even negative, depending on the materials you're using. And so, I think he was saying that the cost of the envelope is roughly the cost of the envelope related stuff is roughly 25% of the cost of a building. That tracks similarly, that's essentially this similar numbers to the percentage of embodied carbon that's related to the envelope. It's a small part of the of the overall math, and so I think it's just important that we remember that when we're talking about embodied carbon, making sure that we're not using a bunch of concrete or steel is really critical. And, we've made some, smart decisions about low embodied carbon materials in the envelope. That's even better.
Yeah.
It's like massively it's very rapidly offset by the operational carbon benefits of a high performance building.
Yeah. So, the main point there was building is expensive. Building well isn't that much more expensive.
Right.
He said that approximately 25% of the overall costs are in those elements that contribute to the thermal performance, a lot of which you're going to have there anyway. So to do it better, it is incrementally smaller, which is a useful argument when the issue of cost inevitably comes up. So really useful stuff there, and the affordability aspect is obviously a big part of it. So got to prioritize those elements. You want to talk about solar panels?
I do. Yeah. So I thought it was interesting to the note that the solar panels embodied carbon is one of the bigger pieces of the embodied carbon calculation for this project, and also recognize that we all know that we need to move to, in terms of our energy system, we need to move to renewable energy. We need to move to solar panels and to wind turbines everywhere. And so, yes, definitely energy efficiency first, but let's also remember that the embodied carbon of solar panels is actually going down quite rapidly. And there's a study that my colleague and friend Skylar Swinford shared from a group called Etude, showing that there's like a typical assumption that the embodied carbon of a solar panel is 2,500 kilograms of CO2 equivalent per kilowatt produced, I think. Nah. Anyway, the point is, I don't know. I don't understand KWP. Anyway, the point, but that by 2020, the actual embodied carbon of panels had already gone down 76%, compared to that kind of typical assumption. By 2040, it's expected to be 87% lower than that, 92% lower by 2050. So like everything, we're going to see the embodied carbon of panels go down, and the payback is really fast. So like the energy production of these panels pays back that really, really quickly. And if you were to then divide the embodied carbon by whatever 20 years of energy production from that panel, the carbon intensity of that energy from that panel would be incredibly small compared to energy from other sources, right? So it's I think it's valuable, I think, to do these exercises where we're thinking with net zero on homes, but in the bigger picture, we want to see this energy transition away from dirty energy to clean energy, including solar panels. So we really want to see solar panels everywhere and more of them. We want to reduce the overall energy load through energy efficiency. So yeah.
So I guess there's a few things in there. One is we want to completely dispel the myth that solar panels take more energy to produce than what they themselves produce in their lifetime. I think we should get over that.
Yeah,
but I know that
it takes a year to offset.
That myth is still out there. But not just energy, carbon. Yes, they are carbon intensive per unit of mass and material, but the downstream benefits quickly pay back in carbon payback years as well as in just pure energy. But I think the other point that we discussed earlier is that they're often seen as a bit of a trick, a dirty trick to offset inefficiency, and I think it's important to separate those things, because yes, we need efficiency first, but there are so many other benefits to adding PV to a building that's already there. It's not a substitute element because it's not part of the envelope. So you're not choosing solar panels versus a roofing material. Your roof is still going to be there, so you need to do that part first, but you may as well cover it up with PV because it's a much better, particularly in somewhere like Australia where there's such a high amount of coal in their grid. So the electricity supply is pretty dirty in Australia. It's a really big difference from here in New Zealand where we have a lot of hydro. But there's still a lot of benefit for having your own generation, particularly as we electrify more of the house, but also electrify our transport fleet as well. So
well,
I think it's there are obviously lots of complexities. But it is an important part of the overall picture of sustainable urban environments.
Yeah, well put. KWP stands for kilowatt peak of a system. So right. If you're curious, no, I think that's well put. And also just and the one last thought about this is that in the United States we have the IRA, the Inflation Reduction Act. I was at an event last night where a journalist from Canary Media pointed out that it's a $400 billion bill. Like $400 billion of investment is going to go into clean energy, and everything, and the elements in the IRA. For context, the New Deal that Roosevelt's New Deal back, that was this massively important moment in U.S. history, was $60 billion adjusted for inflation. So the IRA is huge, and we need to build so much clean energy around the United States, and it's not easy because there's backlash, there's NIMBYism, permitting can take a really long time. So I think that if we can, in the Passive House community, I think we can embrace solar panels on roofs because it may not be it's not as cheap as solar panels in the desert. But we need to see solar panels wherever we can put them, that's fair and doesn't pave over sensitive ecological spaces or important culturally important spaces. We've got a big task, and if you have space for a solar panel, I think that you should use it.
Yeah. So I think what we're saying is that efficiency first, the concept of efficiency first, it doesn't have to compete necessarily with PV or mean that you shouldn't do PV on your passive house.
Right. Well, it's all the same, right? It's the same. It's solving the same problem, because if we also make our homes more efficient, we don't need as many of those solar panels out in the desert. It's all. So
it's still efficiency first,
right? All right.
I hope
this is going too long. I'll stop talking.
I hope the Inflation Reduction Act gets a musical. I mean, the New Deal is the basic premise of Annie, isn't it?
Oh, that's deep, man.
I'm looking forward to the Inflation Reduction Act, the musical.
yeah. I'll say go. I'll start working on that.
In the meantime, there's probably some other events coming up.
There are, although this week we're taking a little break. In the US, we're celebrating July 4th, and so we're going to July 5th would be the Passive House Accelerator live date, but we're taking it off. So because so many people will be away on holiday. So we have a little lull in Passive House Accelerators programming. There's other stuff going on that we will include a link to in the show notes. In the
Awesome.
other stuff going on in the community, I mean.
Yeah. And also, speaking of the show notes, we'll definitely put some links. There's heaps of resources that Talina and Andy put together, including PDFs of all of the PHPP outputs, plus all the design analysis, basic concepts of all of their submission for that competition and all the results. So check that out. Heaps of really valuable information and some really great analysis of the different levels that they modeled for, showing kind of the diminishing returns after a certain point, and also, of course, the value of using PHPP as a modeling tool. Awesome. All right. Well, thank you for that.
Thank you.
Thanks, Zach. We'll be back again next week on the Passive House podcast. So have a great week. We'll see you then.